All right, today is our very last lesson of the year. And we're still talking about circles. So this is our second lesson for circles. We talked about secants and tangents and radii and diameters last time and lengths of segments. Today we're going to be talking about angles in circles. So I want to do some definitions first. So if you have your math journal out, go ahead and copy these down. If we have a circle C, I want to talk about some angles here. So here we go. Call this A, B, and I'm going to put another point over here of D. So first let's talk about angles. We have angle ACB is a central angle. And I want to talk about this because a central angle has its vertex in the center. Makes sense, right? Central angle. So a central angle with vertex in the center. Notice that C is your vertex here for this angle. Now let's talk about arc. Arc AB. This is called a minor arc. So when we talk about a minor arc or any arc measure for that matter, the arc measure is measured in degrees. And so whatever the measure of the central angle is, that's also going to be the measure of the arc. So a minor arc, you can think of minor and then we're going to talk about major. Minor arcs are less than 180. That means a straight line, right? Or half a circle. So it's less than half the circle. Less than 180. And the arc measures are equal to the central angle measure. So if angle ACB is 45 degrees, then the arc measure of AB is also 45 degrees. They're equal in measure. All right, now let's talk about a major arc, ADB. This is called a major arc. Major arcs are larger than 180. Let's write that down, major. Larger than 180 degrees. So it's more than half the circle. And notice that I labeled the major arc with 3 letters. If I just labeled it AB, then I would probably think that this was the minor arc, but I want to go all the way around the circle. It's larger than 180 and it's named by 3 points on the circle. All right, so those are a couple of definitions there. The other definition that I want to talk about is an inscribed angle. So here I'm gonna try to draw a straight line here. So angle ADB is called an inscribed angle. Inscribed angle. And let's define it down here. An inscribed angle has its vertex on the circle. On the circle with, let me find this exact definition. Okay. An inscribed angle has the vertex on the circle with an intercepted arc. So notice that our inscribed angle here is ADB and the intercepted arc here is AB. The measure of the inscribed angle Notice that our measure of our central angle is the same, but the measure is half of the intercepted arc. So if AB, the intercepted arc, is 45, then the measure of ADB is going to be half 45. So it's 22.5. All right, so let's look at some examples with these central angles and inscribed angles. Let's take a look here. So if I have an example here, if I have a circle, here's our example 1 of P, notice that I'm using the center, here's P, and I have a couple of lengths here. I have a diameter of TR, then I have a chord of RQ, and I have a chord of TS. And I'm going to put some measures in here. This is 50 degrees, and this arc is 48 degrees. And I want to find the measure of angle T, and I want to find the measure of arc QR. So it's looking like this. Okay. So if I want to find the measure of angle T, that's this one right here. Look at its intercepting arc, right? So I'm going to highlight this so you can see it. It helps to add some color. Here is my angle, and there's my intercepting arc. So we're going to consider angle T an inscribed angle, right? It has the vertex on the circle with an intercepted arc here. The measure is half of the arc measure. So if the arc measure SR is 48, then I know that my angle T is going to be 24 degrees, right? All right, let's look at the next one. It's the measure of arc QR. I'll use a different highlighter. Arc QR. Ooh, I think about it. Oh, I didn't want to do QR. I wanted to do QT. Sorry. QT. Let me get another highlighter. That wasn't very fair, was it? All right, so if I want to do QT, here's QT, and I have an inscribed angle. QT is the intercepted arc of this inscribed angle, R. So, same thing, if the inscribed angle is half the measure of the arc, well, we just go the other way. Here, from arc to angle, we divided by 2. If I go from angle to arc, we're going to multiply by 2, right? Makes sense. All right, let's add one with some algebra here. All right, here's one here. Here's our example 2. So that one we did was the inscribed angle. Let's talk about one with a central angle. So here we have circle A, and we have some radii here. This one is Y, this one is X, and this one is W. All right, they give us some arc measures. Notice that all of these are central angles, right? So this is 65, this one is 135, and we're looking for the measure of arc WY. So we're just going to make some predictions here. If this is 65, or make some notes, then I know that my angle, my central angle is also 65 because central angles are congruent to the arc. All right, and then the same thing here, if that's 135, this is also 135. So just to kind of notice that. Bigger picture here is I want to know what WY is. So I want to know what this arc measure is. Now I think we're dealing with a circle, right? So if we're dealing with a circle, then if I'm adding these together, I know that I'm going to equal 360. So I know that this 135 plus 65 plus this value, we'll call it X, equals 360 degrees, right? Because all the way around the circle is 360 degrees. You already knew that. So let's do 135 plus 65. 6, that's 9, that's 10. 200 sounds good. Plus x equals 360. We'll solve for x in this case. So subtract 200 on both sides. And we get x equals 160 degrees. So the measure of arc WY is 160 degrees. Same thing, the measure of the angle here is also 160 degrees. All right, that's your answer there. Okay, so go ahead and go do your practice. Good luck. I'll see you in class.